Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Apache 2 licensed chatbot, GPT4All-J, Groovy, and Langhain. So what is the challenge that is solved by GPT4All-J version? GPT4All-J is a quantized model that has been developed by GPT4All-Nomic from the base model of gpt-j. gpt-j has been created by Eleuther AI, and the main USP, that is the unique selling point of GPT4All-J, is that it can run on a CPU because it has been quantized. The point of quantizing the models is the necessary, the objective is to give everybody an opportunity to work with large language models. That is the primary objective. And this GPT4All-J model comes up to 3 to 4 GB of size, and it can, reliably run on a good i5 Intel processor with, it needs at least 8 GB of RAM. That's what I have seen. Without that, the execution environment, that is a Python execution environment, starts crashing. So that is one of the issues that I was mentioning here. I have mentioned at least 12 GB of RAM is required. It actually depends on the processor as well as the hard disk that you are having. The performance wise, it is claimed that it is comparable to GPT-3, that is OpenAI's GPT-3, but the model, as you will be seeing in a couple of minutes when we start working on the example, you will see it has a long way to go. Also, one of the challenges you will see is that longer prompt takes more time to return answers. You will see you might have to wait for considerable amount of time for the particular model to return the various answers. Okay, so I have been talking about not just the challenges it has solved, but also I'm talking about the challenges that it creates. But also let me add some notable developments. The chain of thought prompting can be implemented, and it can be used efficiently with text question answering. You will see that there is some challenges in this also, but still we can use it efficiently. The tokenizer model used for embedding documents can be any sentence transform model, because we will be using a different way for using the question answering process. But see, at the end of the day, we are trying to incorporate Langhain also into this. You can use the retriever. The challenge currently that I was facing when I started working with the GPT4All-J model is that the existing embedding, so I'll be sharing a couple of information regarding the embedding models also, but the existing embedding model was not working very effectively with the GPT4All model. So it was not, working together. I'll explain to you what is the challenge in a couple of minutes. So this is the pipeline, QA pipeline that we will be using. So GPT4All LLM chain will be running in parallel to the text data that we are going to store in the vector store. And there will be a separate Python function that takes the user question, retrieves the necessary context, and sends it to the LLM for the answering. So this is a pretty common QA pipeline that I have been using for a couple of my existing videos. The reason why I'm using this is whenever the Langhain retrievers, the existing methods that is available in Langhain, don't work, then I resort to this option. The reason is very simple. At the end of the day, our intention is not to only rely on the programming frameworks like Langhain or programming frameworks like Llama Index. We need to also understand what these programming frameworks are creating underneath, so that we can develop better softwares. With that said, let's move to this particular slide. Exactly provides the various modules that we need to pull into the execution environment, and then we need to work with the GPT4All-J version Groovy bin. So the link for this will be also shared. So it's by now you must be knowing how to get it. The difference here is that we will be using the LLM prompt, the template that you see here. That is what we will be using, and we will be using something called as question and text. I'll be sharing all these things in a couple of minutes in the GitHub, in the Jupyter notebook. and this is the two of the functions. So this get text function is what, this is the retriever function that I was talking about. So this particular function is what you see here, the get text question. So the user question is sent to it, and it connects with the vector store, gets the necessary text data, and then returns it. Here it is also printing so that you guys can see what is happening. And then we have the retriever answer. So this is the function that is taken care by this particular box where the LLM answers the question. So I get the text, the supporting text using this get text function, then run the LLM chain based on the question that is provided by the user and the supporting text that is received from the get text. So it's a pretty simple way of testing out the large language models, and to see whether it can be usable for our integration with other applications. With that said, let us go to the browser. This is the model card of GPT-j 6 billion, the Eleuther AI, the base model from which the Nomic GPT4All-J model has been created. So you see this. Okay, if you guys are new to Hugging Face Hub, if you have never come to this website, I would suggest that sign up for an account in Hugging Face Hub, and then get access to all the models and various tasks these models can perform. If you are, there is an entire playlist where I discuss about the various open source libraries as well as open source models, the tasks it can perform. So you can take a look at that. You will get a clear-cut idea what's Hugging Face Hub and why I have an entire playlist, almost 31 videos on related to open source models, because there are lots of opportunities out there with the open source models itself. And learning how to use the open source models is becoming more and more important as the development of large language model progresses. With that said, I would like to move and start discussing on the Jupyter notebook that I have already uploaded into the GitHub repo. So this particular notebook, you can always download it and use it in the Google Colab environment. This particular Colab environment is a basic environment. I am not using GPU, as you can see here. And what I've done is, this is the location, this is the link for the location of the GPT4All-J version Groovy model. So you can just use the wget and get this particular model. It's around 3.52 GB, as you can see here. And then what I'm doing is, I am using the GPT4All primitive class inside the Langhain library, and I am creating the large language model here. This is the first step, and in order to do that, I need to create the callback. So this basically creates a kind of a streaming output for the large language model, and the context and also the backend. In case of GPT4All, the primitive, there is initially I was having the challenge that how to enable GPT4All-J, because I see only GPT4All inside the Langhain GPT4All class inside the Langhain library, but I was not seeing any GPT4All-J class. But then later I realized, after researching, that okay, Langhain team has already released the support for GPT4All-J model. All we need to do is create a backend called as gpt-j. By using this particular option, you can use the GPT4All-J version. So this is the key point that you guys have to remember. And most important point is that I had tested the GPT4All model, the basic model, using various questions, and I find that it repeats the answer. So if you ask the question like who landed on moon on July 21, 1969, it repeats the answer. This is something that I found one of the quirks of this model. But anyway, at the end of the day, the model is giving the answers that is coherent, and it is also making sense. So from the perspective of, let me go back to the PDF. From the perspective of comparing it with GPT-3, yes, it is having comparable performance when it comes to making sense, giving coherent output, all those stuff. But yeah, if you're going to, the next step is we have to compare it, how well it does with question answering, how well it does with various tasks, right? And that is where we have to concentrate. we can always take a look at the various parameters, how much training has been done, and there are lots of things you can learn about the model. But as an application point of view, our concentration should be on how to use the model in production, how to use the model in creating new products, right? So here I've created a simple LLM chain where I say, okay, use the text below and answer the question, and I give the question, and then I give the text also below that. The expectation here is that the LLM has to look at the text that is below and it answers the question, right? Okay, what I have found is that, let me show you what I have found. So don't worry about what is going on here. Let us go down straight to the place where I am trying out something. So, okay, basically I have given the text, a bunch of scientists bring dinosaurs back, mayhem break loose, etc. So this is a kind of a context that I create, and then I am asking who brought the dinosaurs back. Ideally, the large language model has to provide simply the answer as bunch of scientists, but it does not. The GPT-4All has been trained on the existing data that is already out there, and it follows it uses the data that is available with it first. It does not, at this moment, at least the way I have initialized this particular large language model and the QA pipeline, it did not look at the context that I have provided. So this is one of the, it did not actually go as per the instruction that I have provided, right? It did not look at the text that I have given at the bottom, that is below, and do the activity. Let me go to the top where so I have clearly instructed it, use the text below and answer the question, but it did not. Why it is the case? So as I was telling, large language models, especially like GPT-j, and are having parameters, only 6 billion parameters that is getting trained. So based on the number of parameters that it is getting trained and the type of data that it is getting trained and the samples that it sees, the level of the efficiency of these models vary a lot. And the best way to go forward will be instruction tuning these models. There is possibility to instruction tune Nomic GPT4All-J as I showed you. So there is a separate video where I discuss on instruction tuning using txt instruct. You guys can actually take a look at that. So when you have a model that is extremely, it is a good output, right? I am not still going into how I have done these things. I will just show it to you, the output. So the output is still good. So it says that there are many people who could have brought dinosaurs back to life, including scientists, researchers, and even ordinary people. And then it doesn't stop there. It actually goes, it is a long error that I got because of the keyboard interrupt. So let me show it. And then it says it is likely a group of scientists brought the dinosaurs back. So this is something that it is, in some way, it is actually looking at the data that is provided to it, but not immediately. So there is some kind of still that needs to be a good deal of improvement. But it's a good start to begin with. With the output you guys have already seen. So let me walk you through the code. What I've done is, after I created this LLM chain using Langhain, the next step I have done is I have used Hugging Face embeddings. Again, this is also a Langhain primitive, which helps to bring the sentence transformers model, that is embedding models, into the execution environment. I'm using Langchain's document again, and these are all toy documents. These are all not any kind of. This is basically these examples I have taken it from Langchain documentation itself. So I was looking for implementing self query retrievers. That was the main intention why I started this particular notebook. Then I ended up working on GPT4All-J. So when I start learning things, I try to club a lot of things together so that I can learn multiple things. This is one of the good way of testing it out. So I was trying to incorporate metadata of the information, and I was trying to work with Chroma DB. So if you see this particular documents, this is a list of documents that I am pushing into vector stores. That is Chroma vector store. And then what I'm doing is I'm using the embeddings that is given by the Hugging Face embeddings. It's a simple way of initializing it. I'm not using any persistence here. I'm just using it for a couple of minutes to just show what is going on. And then I'm running a similarity search. So you can see that I asked for movie on a dinosaur, and I see the first result is on a bunch of scientists bring back dinosaurs and mayhem break loose. So yes, the vector similarity search works well with simple all mini LM L6v2 model. It's 100 MB model. It's not very huge, but when you are trying to work with the GPT4All-J, you might actually think about using the other GGML models that is already quantized. See, I don't have any issues in using those models. However, the challenge there is they take a considerable amount of RAM. So in this case, this particular embeddings just take 100 or 200 MB of RAM, while the GGML models might actually take little more, say 500 to GB of RAM. It depends. If you guys have a good deal of RAM, then you can try it with those models. But when you have a smaller model, always go for it. And the good thing about smaller models is it is faster. Always keep that in mind. It's not with the bigger model, there is a trade-off you always make with the speed. There are a couple of models when you have to bring in GPUs for having the speed. Even if you are going to work with the nomic model that is inside the Hugging Face hub, the 6 billion model, it's better that you have GPU, or else it's not going to even load. So there are challenges like that, which has been tackled by GPT4All-J. So that is the primary point the nomic team is working after. So it is better that we work with smaller models, right? And then what I do is, once I do the similarity search, I just see how it works, and then I create this particular function. This particular function simply does the same thing, similarity search, with respect to the question. So this could be any question that is given by the user, and then I run a simple for loop to get the text out of these questions. Again, another one function where I give the question again, but in this time I'm going to give the context as the supporting text, and then I run the LLM chain. So this is what I'm doing here, and finally you see the output here. We already discussed how the output is and what are the pitfalls that GPT4All-J model has. What I'm trying to say here is that maybe currently you see that if I use this particular model for working with Q&A, it's not working well, but that may not be really the case. The point of always, if I go back to the PDF, I always say that the most important point is that you guys practice. Okay, and the more you practice, try to work with different prompts, try to work with different models, try to work with different length of the embeddings, you will find different results. And large language model, the artificial intelligence domain itself is progressing rapidly. So giving the time necessary for understanding these models, why it is creating such outputs, and how to improve those outputs, these are things that you have to experiment with. I hope that you understand and you like this kind of content, and do leave a like and share. Let us go back to the browser. The point I want to reiterate here is that you see here the output. There are many people who could have brought the dinosaurs back to life. This particular sentence still makes a coherent output. This is actually, it is as if it has been written by a human being, right? This is possible because the GPT4All-J model is properly instruction tuned, and it is trying to answer the question directly. This question, it's not thinking about anything else. It is just trying to answer this question. It is not even looking at the context. Why is the case? Because the internal workings of the model actually pushes. So based on the statistical modeling that the program, the tuning has done, the most likely words that has to come after who brought the dinosaurs back in 5 words, this particular sentence is there are many people. So this is what is already programmed into the model. I mean, it has been trained into the model. That's why it is working this way. Understanding to that level, I am not going into the algorithm. I am not trying to explain to you the theory behind the models. The reason is, to a certain extent, we don't need to understand the theory. But when things don't work out, right? Like in this case, it did not work out, right? You see, I am giving this particular sentence, and basically the model should have replied that, okay, the model should have basically replied that the bunch of scientists brought the dinosaurs back to life, but it did not. Then you need to understand why this is happening. And when you're going to create, when you're going to develop your own application, your own softwares with the open source models, these kind of unexpected results can actually, create a lot of frustration. So that is the reason why I again and again insist you guys to practice with different kinds of prompts, different kinds of embeddings, texts, and then see how it breaks. Because if you guys look at the various other data, that other materials you have got, most of the time you see the large language models are doing awesome work. But in fact, most of my data that you see, I actually show the reality. See, at the end of the day, you have to create products that work, right? You have to create products that meet the customer's demand. And customers have lots of dreams nowadays that large language models are going to change the entire way their system works, or their organization works, their product works, etc. You as a developer or a senior leader, you have to know not just the, as I was explaining, not just the challenges or the pros of the model. You have to understand the challenges, the notable issues of the model also, and also understand the notable developments. These are all developments that is happening. Working with efficiently working with question and answering is one of the key aspects of a large language model. If it can work with the context, then it can do a lot of things. You can use this particular use case on various other use cases. So that is one of the reason why I tried to test it with text question answering. And another use case that I always work with is prompting with multiple type of input, like question and text, as you saw in this particular example. So I use this LLM chain, right? Whenever I get a new large language model that is getting released, I always first test it with LLM chain inside Langhain. That is a first test that can tell whether the large language model can follow the instruction. Here it still follows the instruction, but not to the word. It does try to answer the question, it does try to provide the coherent output, but still it has to go a long way. And moreover, in my case, the retriever, I have not used the retriever. I have used the Python function that has been created by, I have just written a simple Python function. So I hope that you understand what is going on, and whenever you are developing with the open source model, keep these key points in mind, the issues that is there and the notable developments. And when you practice, you will also come across different issues. Do let me know through comments with the various issues that you are coming across, so that I will also be aware, and I will also do some research from my side for improving and giving back to the community. And if you find any notable developments, like if you find any mistakes in my code, or if you see that, okay, Kamal, you could have done it this way, do share those ideas with me. So in that sense, I can improve myself too. With all that said, let us go back to the browser and see what has happened actually. And here, see what happens in the zone. Okay, who brought the dinosaurs back? So you see this, I have clearly told, okay, do not, I have told who brought the dinosaurs back in 5 words. Okay, I have told that it should not exceed 5 words. So what it has done, it has simply repeated the question that I have given. Okay, so this is not something that you expect, correct? But that is the current scenario of these models. And as I was telling, they are efficient to a certain extent. It can produce the text, but whether the produced text, whether it can be useful, whether you need to test it with a lot more data, it is all in your hands. Okay, so at this moment, GPT4All-J is a good model. To my knowledge, it's a very good model if you are going to use it as a regular LLM, AI agent. It should not be a very big issue. But if you are going to try to make it work with large prompts, which is complicated, it has to follow a lot of instruction, then I wouldn't suggest going with GPT4All-J. It's better to go with the StarCoder, another model that I had discussed earlier. That actually goes through coding process, and it is much more controllable than compared to GPT4All-J. And I'm not giving a kind of a proper comparison between models, right? For me, the comparison comes from the usage, how I am going to use, and the real world usage is the way the Hugging Face Hub has a separate series of spaces where they discuss, where they compare the models. So these comparisons actually are made based on the data sets, made based on the output, on the tasks that these models can perform. But for me, when I am discussing and when I am sharing the details with you guys, it's always about some of the challenges that I have. Like for an example, I have a question answering. I need a question answering bot. Most of us are right now, looking for a very efficient way of searching huge amount of data and answering on that, right? And that is something that the model has to work properly. And for that, you don't need to compare models. You don't need a tabular column comparing it. All you need to do is take a Google Colab notebook like this, pull the models using with the various class primitives, and start trying out. So once you start trying it out, you will see how the models are faring, and then automatically you will understand, okay, whether I can use this model in production or not, and what needs to be improved. So I hope that with this introduction about GPT4All-J, you got a clarity on what is possible, what are the developments, what are the issues, and a little bit of background about GPT-j. And you saw how the QA pipeline can be implemented. I used this earlier also with another one model, and I believe that you like this video, and do leave a like and share it with others. Most importantly, subscribe to my channel for further videos on similar kind of topics related to large language models, AI models, Python libraries, and the ecosystem around Python libraries. With that said, I would like to leave with 4 words, that is practice, 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 practice. See you guys. Have a great time.